Hello everyone, let's solve question 49 of GATE paper CS1 2025. Let A be a set of non-negative integers. Let F be a set of functions from A to itself. For any two functions f1, f2 belongs to F, we define f1 uh, f2 to the power n is equal to f1 of n plus f2 of n. For every n in A, which one of the following statements are correct about the mathematical structure? So in order to solve this particular question, let's actually understand its prerequisite first, and then we will try to solve it. So set of functions is given. A function f be a set from A to itself. That is, every f basically belongs to F, maps to a non-negative integer n to another non-negative integer f of n. Now, binary operation. This is what we are calling the binary operation, represented by a circle dot in it. So, it is defined as f1 binary operation f2 of n, f1 binary operation f2 of n is equal to f1 of n plus f2 of n. This is what is given in the question. Now, uh, so it is a point-wise addition of two different functions. Let's understand some algebraic structures to solve this particular question. Let's first understand what a semigroup is. So, a set is associative, a set with an associative binary function is a semigroup. What is a monoid? A semigroup with an identity element E such that A into E, what is an identity element? E such that A into E is equal to E into A is equal to A, where A belongs to this particular semigroup. So a semigroup with an identity element E such that E into A is equal to A into E is equal to A, we call as like monoid, a group. A monoid where every element has an inverse with respect to its operation, we call it group. So a monoid with every element has an inverse, but a Labian group is a group uh, where the operation is communicative. So you can see that is kind of a chain. What chains are there? So first of all, there is a semigroup. Now, what a semigroup is? Semigroup is basically, let me write that. Set S with associative binary function. So a set with an associative binary function is known as semigroup. Now, what is a monoid? Monoid is a semigroup itself with an identity element. So it is a semigroup with identity element. Now, what is identity element? Identity element E is basically A into E is equal to E into A is equal to A. Okay, where A belongs to this particular S. Okay, particular set. Okay. Now, what is a group? A group is a monoid. Group is basically a monoid. So you can see that we are going branch by branch. Monoids are part of semigroups. Like semigroups are parts of monoid. Monoids are parts of group. Labian group is basically, so it keeps on increasing the branches. A group is a monoid where F and F inverse exist. Every element has its inverse. Okay. And Labian group is basically where the properties are communicative. So A into B is equal to B into A. This is what has been achieved. Let's analyze this. We want to evaluate whether this structure is a group, monoid, Labian, or non-Labian. We don't know that. So in this question, we need to evaluate that. So let's understand step by step. So let f1 and f2 belongs to a function capital F. Then f1, f2 of n is equal to f1 of n plus f2 of n that belongs to A, because sum of two non-negative numbers is always a non-negative number, basically, that we can easily figure out. So let's check associativity and understand whether it works or not. So F1 binary operation, F2 binary operation, F3 to the n is equal to F1 binary operation, F2 binary operation, F3. Let's understand that. So it will be F1 of n plus F2 of n plus F3 of n equal to F1 of n plus F2 of n, that is in a bracket this time, plus F3 of n. So if you observe carefully, then it is true. Basically, associativity of integers is what is happening. Identity element. So we need f naught belongs to f, where f binary operation f naught of n is equal to f of n. So for that, f naught n is equal to 0 for n belonging to a, the zero function. This clearly belongs to f and satisfies the given property. So identity do exist. Inverse element. To have an inverse, basically, each function f belongs to f, there must exist a f1, f minus 1, f inverse that also belongs to f, such that f binary operation f inverse on n is 0. Let's understand that. What is this? So this implies that f1 of n plus f inverse of n equal to 0. This implies that f inverse of n is equal to minus f of n. But since f of n belongs to 0, 1, 2, dot, 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 then negative of f of n will not be in A, not be in A, unless f of n is 0. If f of n is 0, then it will be, otherwise no. So for any f not equal to 0, f inverse does not belong to f, because it will have negative values. So inverse does not exist in general. This is what we figured out from here. Communicativity. Let's quickly check that. So f1 binary operation f2 of n is equal to f1 of n plus f2 of n is equal to f2 of n plus f1 of n is equal to f2 binary operation f1 of n. Okay. So, is it an Abelian group? No, because there is no inverse function, no inverse is available for the general functions. Is it a Abelian monoid? True, because associativity, identity, and communicativity exist. Whenever these three exist, it is a Abelian monoid. Now, it is a non-Abelian group, that is false, because not a group and operations are communicative. There are communicativity here. It is a non-Abelian monoid. That is also false, because it is a monoid but communicative. So not non-Abelian. It is a monoid but communicative. So it is a Abelian monoid. Okay, that is what we can figure out. So answer is option B. Okay, that is f function. This structure is a Abelian monoid. That's it for this particular question. Take care. Bye bye. See you guys in the next question.